Pacific Theater, 1944. American forces need airfields fast. Engineers are racing to build runways on islands that didn't have roads 6 months ago. Coral, volcanic rock, mud. Brutal conditions. The problem isn't just the terrain, it's time. Japanese forces can see what you're building. Every day an airstrip stays unfinished is another day bombers can't launch, fighters can't refuel, transport planes can't land. Traditional earth-moving equipment is slow. Scrapers require constant gear shifting. Clutches burn out. Drive shafts snap. Operators need physical strength just to wrestle the heavy control levers. And then Letourneau's machines arrive. Electric controls. No clutches, no transmissions, just fingertip switches that move 20 tons of steel and dirt like it's nothing. The Seabees and Army engineers watch these machines work and realize something: this changes everything. Back in the States, construction industry engineers are still calling electric systems too delicate for real work, too complex, too vulnerable to the mud and vibration of earth moving. But in the Pacific, Letourneau's equipment is building airstrips faster than anyone thought possible. And by the time the war ends, Letourneau factories have supplied nearly 70% of the heavy earth-moving equipment the Allied forces used. The industry that said electric would never work in dirt just watched it win a war. Before we get into how this happened, quick thing. This channel explores industrial machines that changed construction, mining, and power dynamics. Not just what they did, but why some innovations succeeded while others failed despite expert predictions. If that interests you, subscribe. Alright, let's get back to how one man changed earth moving. Robert Gilmore Letourneau was born in Vermont in 1918, dropped out of school in 7th grade, worked odd jobs, leveler in an iron foundry, auto mechanic, farm laborer. In 1919, working in Stockton, California, he bought a used Holt tractor and a homemade scraper. The scraper broke almost immediately. Letourneau fixed it, then started thinking about how to make it better. That broken scraper changed his life. He became obsessed with moving dirt. Not just moving it, but moving it faster and more efficiently than anyone else. He started designing his own scrapers, his own tractors, his own everything. By 1929, he'd founded R.G. Letourneau, Inc. Over the next decade, the company revolutionized earth-moving equipment. Rubber-tired scrapers, the Tortipole, a two-wheeled tractor that could pull massive loads. Innovations that made construction faster and cheaper. But Letourneau kept running into the same problem: mechanical drivetrains. Traditional scrapers used diesel engines that powered wheels through clutches, transmissions, drive shafts, and final drives. Lots of moving parts, lots of friction, lots of things that could break. Operators had to physically wrestle heavy control levers. Shifting gears under load burned out clutches constantly. Drive shafts would snap, final drives would fail. And here's the thing about mechanical systems: they don't scale well. The bigger the machine, the more stress on every component. You couldn't just make everything 30% larger and expect it to work. Letourneau started thinking about electricity. The idea wasn't new. Electric motors had been used in industrial settings for decades. Factories, ships, locomotives, all used electric drive systems. But construction? Nobody thought electricity could survive the brutal conditions of earth moving. Mud, dust, vibration, temperature extremes, mechanical shocks from hitting rocks and stumbling through rough terrain. Industry engineers looked at electric systems and said, too delicate, too complex, too many things that could go wrong. Letourneau disagreed. He saw advantages nobody else seemed to notice. Electric motors deliver constant torque across their entire speed range. Diesel engines have power curves. They're weak at low RPMs, strong in the middle, weak again at the top. Electric motors just pull, consistently, from 0 to maximum speed. Electric systems are also modular. If a motor fails, you swap it out. With mechanical drivetrains, failures cascade. A broken clutch can damage the transmission. A damaged transmission can destroy the final drive. And most importantly, electric controls are precise. Instead of fighting heavy levers, operators could use fingertip switches. Instant response, individual wheel control. The question was whether electric systems could handle the abuse. In 1944, Letourneau introduced something that changed the industry's mind: electric controls on his Tournapole prime movers. Not full electric drive yet. The wheels were still mechanically driven, but the steering and the scraper winches, electric motors and controls. This was the breakthrough nobody expected. The military was desperate for faster construction. Building airfields in the Pacific required moving massive amounts of material under impossible conditions, often under fire. Letourneau's electrically controlled scrapers were faster. Operators could control them more precisely. Maintenance was simpler because electric motors had fewer failure points than complex mechanical linkages. The Army and Seabees started ordering them by the hundreds, then by the thousands. By the end of the war, Letourneau factories had produced approximately 14,000 bulldozer blades, 8,000 scrapers, and thousands of other units, sheep's foot rollers, cranes, specialized equipment. Almost 70% of the heavy earth-moving equipment the Allied forces used came from Letourneau, and all of it proved that electricity could survive in dirt. After the war, Letourneau went further. In 1950, he unveiled the electric wheel. This wasn't just electric controls, this was full electric drive. The diesel engine didn't power the wheels mechanically at all. It drove a generator. The generator produced electricity. Electric motors mounted directly in each wheel hub provided traction. No clutches, no transmission, no drive shafts, no final drives. Just electricity flowing through cables to motors in the wheels. The engineering was elegant. Instead of a central drivetrain losing energy through friction and mechanical complexity, power went directly where it was needed. The advantages were immediate. First, operator skill requirements dropped. You didn't need physical strength to control a machine anymore. Fingertip switches replaced heavy levers. This lowered the barrier to entry and made operators more productive because they weren't exhausted from wrestling controls. Second, maintenance got simpler. Mechanical drivetrains had clutches that burned out, transmissions that needed constant service, drive shafts that snapped. Electric systems had fewer moving parts. Motors could be swapped like modules. Downtime decreased. But here's what's interesting about technology adoption. It's not enough to be right. You have to prove it under conditions where failure is unacceptable. Letourneau couldn't convince the construction industry through demonstrations or white papers. The industry was too conservative. Too many engineers had seen innovative ideas fail in the field. What Letourneau needed was a testing ground where electric systems would either prove themselves or fail spectacularly under the worst possible conditions. World War II gave him that testing ground. The military didn't care about industry conventions. They cared about results. Can you build an airfield fast enough to save lives? Can your equipment survive combat conditions? Can inexperienced operators use it effectively? Letourneau's electric-controlled equipment answered yes to all three questions, and once the military validated it, the construction industry couldn't ignore it anymore. This is the pattern that appears again and again with disruptive technology. Established industries resist change because change is risky. But extreme environments, war, disaster, desperate economic need, break that resistance. The military's adoption of Letourneau's equipment didn't just prove electric systems worked. It created thousands of operators who'd use them, maintenance crews who'd service them, engineers who'd seen them outperform mechanical equipment. After the war, those people went back to civilian construction, and they demanded the equipment they knew worked. The economic consequences were massive. Before electric drive, earth-moving operations were limited by operator fatigue, maintenance downtime, and the practical size limits of mechanical systems. After electric drive, operations could scale up. Bigger machines, longer shifts, less downtime, higher productivity. This directly enabled the post-war construction boom, the interstate highway system, massive dam projects, open-pit mining operations that would have been impossible with mechanical equipment. Modern mining trucks, the ones that carry 400 tons of ore, use diesel-electric drive, direct descendants of Letourneau's innovation. The labor dynamics shifted too. Operating heavy equipment became less physically demanding. This opened the field to more people and changed how companies trained operators. Maintenance crews needed different skills: less mechanical repair, more electrical troubleshooting. The workforce evolved with the technology. Letourneau himself kept innovating. He sold his company to Westinghouse in 1953 for $31 million, then retired to Texas. Retirement lasted about 6 months. At 70, he started a new company focusing on even larger machines. His motto captured his entire philosophy: "Your job's not too big, your machines are too small." He died in 1969, but his legacy is everywhere. Every diesel-electric mining truck, every piece of heavy equipment with electric controls, every modern scraper that can move dirt faster than anyone thought possible in 1944. The technology Letourneau pioneered didn't just change how we move Earth, it changed what's economically possible to build. If you found this useful, leave a comment. What other industrial innovations faced resistance before becoming standard? I read every one. And if you want more stories about machines that changed construction, mining, and the economics of building, check out these videos. Thanks for watching.